In open channels, the water flow is driven by gravity. The law of flow resistance are essentially the same in open channels and in closed pipes. In an open channel, the calculation of the boundary shear stress are complicated by the existence of the free surface and the wide variety of possible cross-sectional shape. The boundary shear stress is proportional to the velocity squared, where F is the Darcy friction factor being a function of the Reynolds number and relative roughness height. Ks, the equivalent sound roughness height, represents the height of the protrusion from the mean profile of the wall. The friction factor may be estimated graphically from the Moody diagram or using the Colebrook-White formula for turbulent flow. The latter may be iterative, also the initialization with the Moody diagram or an explicit expression may facilitate the convergence. Historically, the flow resistance in open channels was estimated using empirical coefficients. Many scholars argue that these outdated and physically meaningless concepts are not promoting the fundamentals of fluid mechanics. And the preceding development, based upon the Darcy-Weisbach friction factor, offers the most rigorous view of the problem. The Shazy and Cochlear-Manning equation express our continuing ignorance of turbulent processes. There is great utility in expressing resistance to steady, fully developed flow in uniform channel in terms of the friction factor. Flow resistance calculation in open channels must be performed in terms of the Darcy friction factor. A seminal application is a uniform equilibrium flow in the channel. At equilibrium, there is an exact balance between the shear force and the gravity force component. After simplification, the momentum equation gives an expression of the normal velocity or uniform equilibrium flow velocity. In natural channels, the flow resistance is a combination of skin friction along the invert and sidewall and form drag. The form drag is associated with form losses and momentum transfer between the mainstream and the recirculation region. And the total boundary shear stress may be decomposed. The following photograph illustrates a real fluid flow across a city, while the following video shows a flow into a rectangular prismatic channel, and the flow reaches uniform equilibrium flow very rapidly until, as the movie continues, it's the water flow downstream until the channel finishes with an overfall.